All right, you're about to take test number 8, which is test 6.8b over position, direction, speed as a result of unbalanced forces. So we're going to go ahead and get started. Looking at the image below, what is the net force, which is the sum of the forces acting on the box? Notice the direction of the arrows and the strength of the forces. Is it A, 0 newtons, so no motion, B, 50 newtons to the left, C, 50 newtons to the right, or D, 100 newtons to the right? Looking for the net force acting on this box. Number 2, we know that the forces below will result in a change of speed and direction because of the forces shown. Are they A, balanced, B, are unbalanced, C, are all equal in size and direction, or D, have a net force of 0? So take a good look at the forces, the arrows, and the strength of the direction. Number 3, the image below shows 4 different boxes that have forces acting upon them. Looking carefully at the boxes, which examples will result in no motion? So there's 4 examples here. Look at each box, look at the arrows and the directions, and of course look at the strength of the arrows. Take a good look at all 4 examples. So which boxes will result in no motion? Is it A, boxes 1 and 2, B, boxes 2 and 3, C, boxes 2 and 4, or D, boxes 3 and 4? Number 4, in the image below, a man is pulling a box with a rope. There are several forces acting on the box. Based on the forces shown, the result of motion on the box will be blank. So again, take a good look at the box, look at the forces, look at the direction of those forces. So the result of motion on the box will be A, to the left with a force of 15 newtons, B, to the right with a force of 230 newtons, C, to the left with a force of 245 newtons, or D, all the forces are balanced, so there will be no motion. Number 5, once the people start to play tug of war, the result will be motion to the left. This is a direct result of blank. Is it a direct result of balanced forces, unbalanced forces, forces in the same direction, or the net force being 0? So again, take a good look at what's going on here. Look at the direction of the arrows and look at the strength of the arrows. Number 6, looking at the image, we know that the image demonstrates blank. So again, first thing, look at your arrows, look at the direction of the arrows. So this image demonstrates A, net force is calculated by 2 forces in the same direction. B, net force is calculated by subtracting 2 forces in the same direction. C, the net force will cause motion to the left. Or D, there is 0 net force on this box. So again, take a good look at your arrows, the direction they're pointing, and the strength of those arrows. Number 7, the toy car is being pushed with opposite forces of equal strength. When the forces on an object produce a net force of 0, we know that the forces are A, moving the car to the left, B, moving the car to the right, C, balanced, or D, add together, therefore pushing the car in the same direction. Number 8, looking at the image of the bowling ball being released, we can see that the bowling ball has motion away from the woman because blank. If you look at the bowling ball, you have some time and distances. So here's our answer options. So we can see that the bowling ball has motion away from the woman because A, the bowling ball is changing position relative to the woman. B, the bowling ball has mass. C, the bowling ball stays the same direction from the woman, same distance from the woman. Or D, the forces are balanced on the ball, causing it to remain still. Number 9. Take a good look at our cart, look at our forces, look at the direction of the force. Number 9, the cart is sitting still, but once the men start to apply their force to the cart, the unbalanced forces will cause the cart to move to the right. This will cause the cart's energy to transform from blank. Is the cart's energy going to transform from kinetic to potential? Kinetic to kinetic? Potential to potential? Or potential to kinetic? You have to jump back to the last unit and we talk about potential and kinetic energy. So right now the cart is sitting still, and then the men will apply their force to the cart. Number 10. Looking at the diagram below, the student is creating an unbalanced force on the table. So looking at the diagram, you can tell he's pushing in this one and he's pulling in that one. The table can both be pushed and pulled, and this motion will be caused by blank. Is it A, a force, B, gravity, C, speed, or D, direction? All right, so I know you guys are taking this test online, so what you're going to want to do is review your questions. If you need to look back at the videos for oral help, please do that again. When you're ready to confirm your test, go ahead and turn it in electronically, and wish you guys good luck.